A mother sperm whale and her calf navigate the deep blue of the North Pacific, passing directly through a massive, tangled web of synthetic rope. The popular image of the Great Pacific Garbage Patch is a floating landfill, a solid, Texas-sized island of plastic water bottles and grocery bags. Actual surface data from NOAA reveals a peppery soup of microplastics. These tiny, fragmented pieces measure less than 5 millimeters, suspended just beneath the surface. In 2016, researchers deployed a military-grade Hercules C-130 aircraft to survey the 1.6 million square kilometer patch from an altitude of 400 meters. While the surface was clouded with microplastics, aerial sensors detected 79,000 tons of large, distinct debris items floating within the zone. The sheer density of this mass raises a specific question. What durable objects account for 79,000 tons of mid-ocean mass, and which industry is losing them? A multi-vessel expedition utilized specialized manta and megatrawls to pull physical samples directly from the North Pacific subtropical gyre. The survey counted 1.8 trillion individual pieces of plastic. The vast majority were microscopic fragments, but the total weight of the haul revealed a different profile. This chart contrasts the individual piece count against the total mass. While 94% of the pieces are microplastics, over 3/4 of the actual mass consists of objects larger than 5 centimeters. Between 75% and 86% of this large floating mass consists of abandoned ghost nets, heavy synthetic ropes, and industrial fishing gear. The Great Pacific Garbage Patch is characterized by the structural runoff of the global fishing and aquaculture sector. This concentration of heavy commercial nets and the relative absence of consumer water bottles is driven by the physics of the ocean surface. Oceanographers define this as windage, a measure of how much surface area an object exposes to the wind above the waterline. High windage objects like foam coolers and plastic bottles act like sails, catching surface winds and blowing back onto coastlines. Conversely, low windage items like heavy fishing nets sit submerged, ignoring the wind, locked in the slow-moving circular currents. The ocean acts as a physical sorting machine, actively trapping the most durable industrial gear in one centralized location. To identify the source of this material, researchers logged individual manufacturing dates, made-in stamps, and specific language markings found on the retrieved gear. The identifiable debris showed a high concentration of Japanese and Chinese lettering. A significant portion of the Japanese gear was washed out to sea by the 2011 Tohoku earthquake and tsunami, which instantly forced millions of tons of coastal material into the water. The garbage patch functions as a record of these events, showing how natural disasters inject decades' worth of industrial debris into the ocean overnight. This accumulation of industrial waste sits within an active migration corridor. Records from the 2016 survey confirm that marine life regularly navigates through this zone. Aerial observers recorded mother and calf pairs of sperm whales, beaked whales, and baleen whales swimming directly within the patch. These animals face catastrophic entanglement as they swim through fields of submerged industrial nets. These durable traps are nearly invisible in the water column and do not degrade. Current data shows that the mass of plastic within the patch is growing at an exponential rate. Solving the Great Pacific Garbage Patch requires a transformation of the global fishing industry before these ancient migration routes become permanent graveyards.